1 means it will not allow the joint to move.
Yes, sir.
Okay. So for member release, 0, 0, 0, 1, 1, 1 means it's almost same like this one. It will not transfer moments.
Moments. Only the shear forces.
Only forces will be transferred. No transfer of moments. But don't get confused. I'm just telling it. We are not using it right now. We will use it later. But just keep in mind. Okay, I'm not
Okay.
using it now. We will go everything in detail again. This is just an introduction. Today
Okay. Okay.
we
Okay.
are just exploring. We will go through everything, and we will make sure you will understand when to use what. Okay, I'm just explaining these things. If you get afraid, also let me know. Don't get afraid.
Okay.
Okay,
Okay, sir. Yes.
because since there are a lot of options, if you do everything together, you will be overwhelmed. Okay, now just keep. I'm just showing what we can do with it. Now, come over here. I told you the centroid will be acting as the joint. Now, in some cases, you may need to offset beams. We will come to that and I will show. So now let's make one. Okay, this is another important part. Here you can see from all sides how it is. So this is from the top view. No, this is from the top view. Okay, so our first joint was 0, 0, 0. Second joint was 0, 0, 2. Now I am creating another joint. Here instead of absolute, I am going for relative. Just 1 minute. So for relative, we are creating a joint relative to some joint. For that, you need to select a reference joint. I am selecting A0002 as reference joint. Okay. I am not giving any fixity. And relatively, I am giving it in Y. 10. So it create a new joint. And I am giving a member. Select B1. So if you look over here, I created one more, right? Okay. So coming to the display, when we go to isometric, we have two types of display. One is perspective, one is orthographic. So as default, SACS will show everything in perspective. But sometimes we may look, oh, why this is perspective? What problem with perspective is, let's say if we take a view from the side, actually A002 and A003 should be just behind it, right? The perspective will show a view like inward, what we see with our normal eyes. If we look at a veranda, how it will show? It will show inward, right? So that is perspective. So if you want to see everything like what you want to see just behind, you click on orthographic. So orthographic will adjust like we look from each point. Is this view clear?
Yes, sir.
This will be very handy because I took almost 6 months to identify there is something option called orthographic when I started my career. Because we created big structure like 20, 30 meter. Every time I am taking screenshot, it was not coming proper. Because in ANSYS and all, we should come proper. Then only we identify that, okay, there is something called orthographic over there. Even our trainers didn't told me. So that is also a very handy feature.
Okay.
Now, uh, I will show you another trick. So another trick is sometimes we may create similar structures. But instead of creating everything, we can use some options called mirroring and scaling. Okay, remember the term mirroring and scaling. Now for that, you should come over here. You should come to this option, translate or rotate. So what it will do is, if you select this option, you can translate the model. That means you can move the model from one side to other side, and or you can rotate the model. So what I am going to do now, first I am going to translate. I want 0, 0, 0 as my center of the structure. What I am going to do now, I will tell you what I am going to do now. So I am going to create a model. I am going to create a model like this. So this dimension is 20 meter. This is also 20 meter. This is 10 meter. And these are also of 5 meters. Okay. Now what I am going to do is, first I will where is our centroid? This is our 0, 0, and this is 10, 10, and this is 10. First I am going to move this total structure towards negative y to make the centroid at some location. So I select all these joints, give -10. So this will translate. So if you want to see the origin ORG, if I don't give anything, it will automatically take as 0. See, it moved, right? It moved.
Yes, sir.
Now I am going to change the fixity of this one. I want to make this free. So I select that one and select it. So now you know how the translation will work. Now, if you want to rotate this one, the default value is 0, rotational origin. So if I want to rotate this, select here. I'm not going to translate. Rotate about Z axis because we are in XY plane. We need to rotate about Z axis. It will rotate like this. See, it will rotate like this. 270. Okay, from there it's 270. Because every time it will take the reference from there. It's fine. Now I am undoing everything. Bring it here. Now I am going to use the mirror function. How to make the mirror function? You need to activate duplicate existing joints. Use existing joint if is at the same location. Then duplicate attached structural elements. So what it will do? It will duplicate the existing joints. And let's say if there is an existing joint, it will use the same joint. And duplicate attached elements means if there is structure attached to these joints, it will duplicate that as well. You come over here, click 90, it will create. Now if I click 180, it will create another one, and 270, it will create. So it will be easy for you to create. It's clear?
Yes, sir.
You are almost clear, right?
Yeah, yes.
Okay, so that's how you will use the mirror function. Now, how to use the scaling function? So now we already told about duplication. We don't want to change anything. Now use the scale function, none. You change it to, sorry, you change it to none. You click on all the joins. Now, what is our length over here? If you want to see the distance, click on this one to show the distance between two joins. Length is 20. Now I am going to make an inner one of 10. So I clicked all these joins. I want to change the factor only in X and Y. Scale factor, create another one. Right? So see how easy it is. Instead of defining each and every joint, we can use these functions to create the model. Is it clear for you?
Yes, sir.
Ganesh, Sandhya, are you
Yes,
guys?
sir.
Yes, sir.
Yes, sir.
Okay. So this is clear. Now see the flow of structure. So you should make sure the flow of the internal coordinate axis should be similar. I mean, because if you are making a single structure, it should not be like this. It should not be like this. Okay. So this is how you will look at the you will check the structure. You need to make that x-axis flows throughout. So it will make the member properties, stress transfer, load transfer, everything smooth. Now I am creating some internal members. Come over here. Okay. So here I am selecting first joint, second joint, and I select on the group level. If I click apply, it will come. Huh? But instead of clicking apply, if I want to do it multiple times, you just activate add immediately. What will happen? If I select these things, it will automatically add. It is saving me one click. It may be small for a small structure, but when we are creating big structures, no, this will be a very helpful trick. So now I have a structure. Now look at our structure. See, this is our structure in 3D. Now, few things. Now look, we look at this this joint, this particular joint. It's not a proper joint, right? It looks weird. It's like a cut section. Do we make frames like this? No, right?
Yes, sir.
How we will make frames usually? Where is the snippet tool?
It should be a miter cut.
Yeah, so let's say if we have a beam over here, we will create a beam like this, right?
Yes, yes.
So you can do this modification, or see in SACS, if you don't do that modification also, it's fine. But some engineers will prefer this perfection. They are all about perfection. So they will ask us to change it. So how to change it? So you know what is the cross section of the member. You click on this one, you click on edit. So this is our length, 10.058, right? 10.058. So if you take the half, how much it will come? 5.029. So you come over here, you select one, go to offset. You can offset like you can offset globally or locally. I am taking globally. Globally, I am going to, if I am taking global, it will be always according to the global axis. So this is X, but in globally, where is X? This is X, right?
Yes, sir.
So where I should change? to extend this one,
Y-axis.
y-axis. So I should go to minus 5.029. See, it got extended.
Yes.
But now if you look, people may ask why you are not reducing this beam. This particular beam we are not reducing, right? Why? Because web is touching over here. Okay, so these are few things which is not that important most of the time. If you keep it like this also, this is fine. Okay, it will serve the purpose. But in some cases, the UC values, the utility ratios will be very high. At that time, we may need to go for these modifications. So this is how we will be doing. We can change the length, we can modify the joints and make it better. Are you guys clear with that?
Yes, sir.
Yes, sir.
Okay. Now do one thing. Uh, let's you guys try. You guys try to create a model like this.
Okay.
Huh?
Yeah.
Try to create. At any point of time you are stuck, share your screen and ask me doubt. Okay,
Yes.
please start. Can we extend few more minutes till you guys finish it? Ganesh, Arun, Sandhya.
Yes, sir.
I think I will stay till you guys finish. So is it okay for you guys to extend
Ah,
the time?
okay. Okay.
Okay, sir.
Okay, sir.
Yeah, okay. Then I will stay. I want you to guys to finish it.
Ah.
Sir, after creating joint, I don't know how to add members. Sir.
Okay. Can I share me your screen?
Uh,
Sir, actually, I added the joint, but it did not show.
Arun, I am not clear with your voice. Can you keep the mic closer to your mouth?
Sir, actually, added the joint, but
Ah,
it not display in our screen, sir.
okay. Let me see. Please share your screen.
Yeah, sir.
I cannot see your screen. Are you guys sharing?
On it, sir.
Okay.
It's visible, sir.
Yeah. You go to the next one. Yes.
Yeah,
Okay.
sir.
So,
Actually, I added, but it's not
okay.
showing.
Okay. I will request control. It's in desktop only. Okay. You do one thing. Go to file. Go to
Sir,
file. Go to settings.
setting,
Go to display.
display.
See. Your top background and bottom background is white. Joined and joined labels. Click it on. Change to black. Black first one. Okay. Click OK.
Yes, sir.
Ah.
Oh, okay, sir. I get it, sir.
Okay. Please continue. Ganesh, for you also it's same. What happened to Cynthia?
Sir, actually, we can do one thing. You can guide Arun so that we can follow Arun, sir, by step.
Okay. Okay. Arun, can you share the screen?
Right, sir.
1 minute. Let me put a message to Sandhya.
Yes, sir. So, yes, yes.
1 minute.
Okay, okay.
Okay. So you created one join. Now do one thing. Create one more join. Go to relative. Join relative.
Relative.
Maybe create joined in X. Put F 10 meter. 10 meter. 10. Apply.
Fixed it, sir.
Fix it. Keep it same. Uh, and the reference join. Select the first join. Select the, can you click on the isometric? No. Come to right. Isometric. Okay.
Yeah, sir.
You have two joins. Now click on the first joined property. Join property. Go to join property on the top.
Yes, sir.
And click on the first joint. Change the fixity to 0. Apply. Sandhya, hello.
Yes, sir.
Sandhya, are you able to follow? Are you able to do it?
Because I got disconnected in between. Now
Okay,
I
it's fine.
joined.
It's fine. Try doing it.
Okay.
You are okay to stay, right? Half an hour.
Yes.
Okay. So uh, now, did you also create the join, Sandhya?
I created the joint and
Okay.
I added a member, but I don't know how to give the property.
Okay,
One
okay.
second.
We will do it.
Okay.
Now go to property, click on property, top, not join property, Arun.
Okay. Okay.
Click on the top ribbon, property, go to member section. You come down little bit down, section types, come to section types. Say, click on white flange, third one. Click on apply type of filter. Now you scroll down to W10 bar 12. W10 bar 12. Or any one of your like, maybe
Okay.
you select anything, it's fine. Now just rename it. Maybe add a B or something to the top. Just B. Okay, that's fine. Click on copy.
Copy.
Okay. Okay, just wait. Ganesh and Sandhya, are you guys still here?
Yes,
In
sir.
Arun, sir. We are following, sir.
Okay, Sandhya, are you following? Are you here?
Member section manager, I'm not getting inside
Okay.
property.
Uh, uh, Sandhya, can you share the screen?
Okay.
Now, who is sharing? Is it?
I'm trying to share.
Okay.
Wait, sir. I will stop my sharing. Wait.
Okay.
I'm sharing. Is it
Okay.
visible?
Okay. Yeah, is it visible?
No, sir, I
So
did
you.
like this.
Okay. It's fine. You
No.
maximize the window.
Okay.
You come to the top left, near bottom of home section property. Sorry, member section. No. You go to
Home.
no, not go to home. You click on property itself.
Property.
Below
Member
home,
section.
member section. Click on that. Okay. You come down. Section types. Drop down is there, no? Click on white flange. Third one.
Okay.
Click on apply type. You click on any beam. It's fine. Now go to label, top one label.
Okay.
Add any number, B or A, any. Yeah, it's okay. That's fine. For now,
Member
click.
001.
No, anything is fine. It's fine.
Okay.
You click on copy.
Copy.
Okay. Now you have a section defined.
Okay.
So Arun, Ganesh, you completed till here, right?
Yes, sir.
Okay. Now close the section manager. Top. Okay. Now near to section manager there is member group, right? Left side. Go
Member
left.
group.
Click on member group. Type one label, any label, M1, B1, anything. Click on add. Okay. Now you come to section label down.
Okay.
So there is, after edit, there is a 3 button, right? So here what we are doing is, it will select all the sections which bring to the section list.
Okay.
Now we defined only one section. That's one section is there. You can click your section name. Click on that. Click on OK. Okay. Now you have assigned the section to this group.
Okay.
If you want to change the properties, you can change, or you can keep it same, no problem. If you want to change the color, come down and select the color. No, not here. Select color. So here you can change the color, any color. Click OK. Click apply.
Okay. Close.
Close. You can close it. So, and Ganesh, are you guys here?
Yes, sir. I'm watching, sir.
Okay. So you define
Sir,
the group as well.
actually, member not came, sir. For me.
No, member will not come. She directly put the member.
Oh, okay.
Okay. Now just Arun and Ganesh, just hold on. I will
Okay,
show one
okay.
thing.
Okay.
Sandhya, you click on the member. Top. No. Click on the top ribbon member after join.
Okay. Okay.
Click on the member property.
Okay.
So now what happened is you created a member. It doesn't have any section assigned. So click on that member. Now you click on the member.
Mm.
See, it shows that your length of the member is 10, but you don't have any section or group label assigned. So if you have any member defined and if you want to assign the group label, you come to that 3 dots after edit. No, you close it there. You come to 3 dots after edit. Click on M1, assign, and apply. Now your member is assigned. If you go to 3D, Ganesh and Arun, please hold on. I will come to you. Next.
3Ds.
Oh,
Next,
okay, sir.
next button. Next button. Yeah, that button. See, your 3D came. Okay, this is how you assign. Now I will show you how to assign a new member from the scratch. Now you go to top delete member. Delete member. Right. Come right. That one. You click on that member and apply. You delete. Okay. Now you have just choice. Now you Ganesh and Arun. Everything is around same page, right?
Yes, sir.
Now go
Yes,
to
sir.
add member. Add. Now come to group label. Third one. You select a group. Your group. M1. Okay. Now go to join day. Click on join day. Click any first joint. Click next joint. Click apply. You have the member. Are you guys still here?
Yes, sir.
Yes, sir.
Clear. Okay, good. Close it. Now you click on that 3D button again. Toggle wireframe. Okay. Now what we will do is we will remove the joint fixities. Okay. You click on the joint. Click on joint property. You select both joints together. Click control and select. Now go to fixity.
Fixity.
Drop down. Select first one 0, 0, 0. Click apply. Okay. Now we have a member with any fixity. Clicked apply. No, I don't think you clicked apply.
Sir, I have one doubt, sir. So initially, while fixing the board joint, we initially fixed the joint at 0, and 111. Again, why we need to
No. We don't want to fix anything. Initially, to show your fixity, I created a joint fixity.
Okay, sir.
Now, for our model, we don't want to give fixity at this point of time. That's why, because we are going to mirror it, right? If we have any fixity anywhere, it will also get mirrored.
Okay.
I don't want to do that. Okay.
Okay.
Now we will create a L-shaped structure. Okay. For that, go to joint relative joint, relative. Click on that second joint. Now click Y relative 10, give 10. And click apply. Okay, now we have third joint, right? Now create a member. Go to member, add member. Add member. Click on the first joint and second joint. Click apply. Stop. Ganesh and Arun.
Yes, sir.
Did you reach this point?
Oh, thanks, sir.
Yes, sir.
Okay, so now what we will do is we will go to translate first. Okay. You go to joint. Go to the translate or rotate. select all 3 joints. Go to Y, translation Y, type -10, type apply. Now what we have done that, we have translated the model 10 meter towards negative Y axis.
Yes,
If you
sir.
want to see the model, click on the isometric tab. Isometric, green one, green, down, 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 down. That go, no, last one. Now everything is in same page. Okay. So Ganesh and Arun, are you reached here?
Yes, sir.
Okay. Now what we are going to do, we are going to mirror it. Okay. Again, click on translate and rotate. Now from the top, there is general mirror bar about duplicate is there, no? Click on duplicate. Okay. So click the first option. So what it will do, it will duplicate the existing joint. Now go to the fourth option. So fourth option, what it will do, click on it. It will use the existing joint if another joint is coming on the same location. Okay. Now choose the next option, duplicate attached structural elements. What it will do, it will duplicate any elements connecting these joints where there. Clear?
Yes, sir.
Okay. Now go to general tab. General. Go to rotation axis. Which axis we should select? In which plane our structure is right now? If you look at the axis, do you see the axis on the left bottom corner? Do you see the axis on left bottom corner of the screen?
Yes, sir. It's along x-axis.
We are in XY axis, XY plane.
Yes.
Our structure is in XY plane.
Okay.
Then in which axis we should rotate?
Z.
Z axis, because Z axis is normal to the XY plane. So go to rotation axis, select Z. Now what you should do, you should select all 3 joints. Okay. Now for rotational angle, type 90. Click apply. Something went wrong. One minute. Let me see. No. Duplicate structure. You general. General. Click on general. Not there. Tab. Not there. Tab. Click on the tab.
Which one?
No. 1 minute. I will again ask for 1 minute. Let me try to. You share again. Where you had seen the duplicate, towards the left side there is general, no Sandhya?
This one.
Click. Is that rotation axis? You go to rotation origin. Rotational
origin.
0. Put everything 0. Click again. Apply. Why it is coming? I need to. You close it. Close. You click on that near isotropic. Third from the left side. Third option. No, view, no. I want to see the top. That one. You go to joint property. Click on the first joint. Our first joint. That is 20. Okay. Oh, you gave 20. Okay. Next one. 20. Okay. 20. Okay, I understand what is the problem. Close it, close it.
Okay.
Type control is that.
Gone.
Control is again. Okay, wait. Now we again go to join property. Click on the joins. That is 0 minus 10. Okay, next one. 10 again. 10. Okay, now it's good. Close. Go to translate and rotate. Go to duplicate. Select our option, first option, fourth option, fifth option. Go to general. Go to 90. Select 3 points. Apply. So do you understand what happened here? Earlier, what went wrong? We translated 2 times.
Okay.
Instead of minus 10, we click it 2 times. So it translated more. So if something goes wrong, it's always better to check the coordinates and see what went wrong. Okay.
Okay.
Ganesh and Arun, are you here?
Yes, sir.
Okay. Now you click again, Sandhya. Click on translate and rotate again. Go to duplicate. Click on our first, fourth, and fifth. Go to general. Select our Select our all 5 joints. Click on rotational axis. Now, what angle we should give to complete it? We need the exact opposite, right? 180. Do 180. Click apply. Now we have this one, right?
Okay.
Now we want to scale it. First, deactivate rotational axis. No? Bring it to none.
None.
Scale factor, 0.5. Where all we should change to 0.5? X and Y, right?
Yes.
Click apply.
This let it be 1.
We are not changing it. No. Before applying, we select the joints.
Control is set.
Select all joints.
Control A. Apply.
Apply. Okay, good.
Close.
Ganesh and Arun, are you guys here?
Yes, sir.
Okay. So this is how you do translation and rotation. Okay, that is fine for translation rotation. Before winding up today's class, I want to show you one more thing. Okay. So you go to join delete.
Delete.
Click on that. No. Click on first one. No.
Specific joint.
Okay. So what if you select any joint and delete? If the joint is not connected to any member, it will delete. Okay. But since we have all the joints connected to members, if you want to delete it, you need to activate the first option, delete or alter all reference model data. Click on that. Select all joints. Click apply. Delete everything. Okay, leave it. Now create 2 more joints. Create 2 joints 10 meter apart. Apply. Next is 10. Okay, now connect these joints with a member. Okay. Now we have a beam. Okay. We are going to do a normal cantilever analysis. Okay.
Okay.
So how we need to do is you go to joint property. You select the first joint. What fixity we should give?
Fixed.
Fixed. Select.
One.
Yeah. Click apply. Now we are having closed. Now closed. Now we are going to apply load. Okay.
Yes.
So go to load. Click on load. Go to join load. Joint. So here, what we will do is we can apply a joint load. Now you click on the second joint. So what we see here is next load condition and load ID. So always SACS have two types. So we can give single type of load in a group. For that condition ID is coming. Now you just put F1 over there, F1, type F1, and load ID gives 01. Now we are going to apply a vertical downward load. Go to FZ, FZ.
Is it minus?
Minus 100 kilonewton. Give 100. Give apply. Okay, keep. Click on keep.
Okay.
Okay, close. Close. Now, if you want to give the self weight of the beam, go to self weight, top left. Load condition, no? Load condition.
Can you please explain once again, sir, that load sign?
Okay. Now, if I want to explain, we have different type of loads.
Okay. Just how to apply load, sir.
Okay. So first, if you want to apply a joint load, click on a joint.
Okay.
So click on which joint you want to apply. So here our free joint is second one.
Okay, sir.
So we say click on second joint. Then we have load conditions. So load condition, we are giving some generic thing. Okay. So here we are giving F1, then load ID.
Okay.
And coming to the load, it should be FZ. Since we want to act it downward, we give negative because our global Z is top. That's why we give minus 100. Then if you give apply, don't click apply, Sandhya. Don't click apply. Ganesh, once you click apply, another dialog box will come.
Okay, sir.
You click on the keep. There is a button called keep.
Keep, yes, sir.
Click on the keep.
Okay.
Then close it. Now close. Sadhya, please close it. If you want to see whether this load came, go to load properties on the left side. You click on the F1 basic. Click on the load ID. You have only one load ID. So you can see, yes, we have one load over here. Okay. Now, if you want to give a member load, you click on the member load. No. Self-weight we will give. Member load. So here what you will give is, we have different option. We can distribute the load. We can give UDL. We can give a total. If I am telling I want to give a total 100 kilonewton throughout distributed, we have a lot of options over here. Now we are not giving, we are just exploring. Go to load category, Sandhya.
Distributed.
So here if you look, we have distributed load, concentrated, temperature, distributed, delete. So we have a lot of options. Now we are going to give any UDL. If you want to give a UDL, I will show you. Just give. Go now. Close it. No. Go to load condition. Load condition. Make it F2. F2. Come to down. Load. Okay. So we are giving a small UDL. Okay. Or maybe we can give a VDL. So give me initial load of -1. Give and final load of minus 10. So if you don't specify distance from the beginning, what it will do is it will take from the beginning of the structure. And if you are if you want to specify somewhere in the between, so our thing is 100 meter, sorry, 10 meter, no? So first one you give 2 meter, 2, and second one you give 7 meter. Click apply. See, you got a VDL. Did you click on the keep?
Sandhya? I click.
Okay. So if you want to give a UDL, you can give initial load value and final load value same. Okay.
Okay, sir.
Okay. Now close it. If you want to give a self load, click on self load. Put load condition as F3. Load ID is, yeah, it's fine. Load ID doesn't care. So self load we use not just for the weight due to gravity. We use for a lot of things, but here we are using for weight due to gravity. So our load direction minus Z. You click on load direction. So we will select minus Z itself because our weight is acting downward. Our acceleration due to gravity put at 1. That means it's a factor of acceleration due to gravity. It's not 9.81. It's a factor. 1 means we are considering 9.81. Now load disposition. Click on load disposition. Click on second one, add to existing. So I will tell you, add to existing means we are creating a new load. Okay. Load placement. No, you put on corner load itself, corner joints. Okay. Now click on apply. It will show you the summation. What is the self weight? You clicked on apply?
Applied and keep.
Okay. Okay. Now sometimes we can get an error. We may click it 2 times. So what I always use a trick as a fail-safe is, instead of after putting add to existing, I will select delete existing. You click on delete. No, delete existing. Okay, just hold on. Now go to load properties. So click on F3. See, F3 is -6 only. Okay, that was our F3. Now close it. You change the delete existing to add existing. Surya. Add existing. You click again. No. You click on apply. You can click on apply. I click on keep. So what happens is we may double the load. Now see. So sometimes error happens. For every time I use self load, what I will do is, after giving the loads, I will go to, you close it.
Sir, 1 second. How to identify whether the load is double?
Okay.
Value.
So now I will tell you. You change it to delete existing. Click on apply. So here you see FZ is 6.157. No. So we need to keep on these values. Look, Arun. So we need to keep on these values. So best way to work on it is keep an Excel sheet parallel with your analysis file. Whenever you see all these values, no, put a screenshot into that Excel file and create a table. I will show you in next class how to create a structured work input so that you will not miss things. Okay, I will come to that part. Now click on keep, Sandhya. Now you again go to load properties, F3. See, it resetted. So when we select delete existing, it will reset all the previous ones to the new one, so that it will not add on.
Okay,
always
sir.
Remember, when you give for first time, you should select the add to existing. But once you give that, then give a delete to existing. So now we have 3 loads. Okay. Now if you run the analysis, what happens is these 3 loads will act individually. Okay. But what we need to have, we need to act these 3 at the same point of time. Clear, right? So
Okay,
for
sir.
that, what we should do, we should combine these loads to a single load combination. So always SACS will act with SACS loads, basic loads and load combination. So how to combine load? You see an option near of combine at the top ribbon towards the right. Click on combine. So you give one combination L01. You click on F1, F2, F3.
Sir, once again, where that option came, load combination data.
In the ribbon itself, where the load is,
Okay, sir. Okay.
you click on that arrow, the change arrow. You click on apply. Okay. Now you again go to load combination, Sandhya. At the click on 3 dots. 3 dots. No, near load combination.
Okay.
So our combination will come. Click on that. Okay. So it will show the load combination. So Arun and Ganesh, are you guys still here?
Yes, sir.
Okay. So here one thing to identify is this is how we will add a load combination. And we can edit the load combination at any point of time. Okay. To click on edit, you see the factor. Sometimes we may need to give more factors. Okay. Here we can change the factors as well. Have you heard about weight growth factor, dynamic amplification factor, consequence factor? Are you guys aware of these factors?
So we just aware of safety factors similar to the
Which factor?
safety factors.
Okay, so safety factors we usually use for LRF designs, no?
Yes,
Yes,
sir.
sir.
Okay, so here there are few factors. Something like weight growth factor. Weight growth factor is when we design a structure and when we reach the final thing, there is a high chance that weight may change because we are going through different iteration. After each iteration, it can come down or go. So for safety, when we start a design, we will consider 20% of weight extra. When we start, that is feed stage. I will tell you about feed everything in the next class. So as a normal, we will consider 10% weight contingency. That means we are considering that even if the weight of the final thing after fabrication, it increases by 10%, it will not harm to us. That is 10% of weight growth. So here it will be applied to self weight. You just forget about those things. We are not applying any factors right now. We just think about the combination. You apply and close it. Okay. Now what all things we did? We defined a cantilever beam. We gave the properties, material properties we give the load. Now we need to do the analysis. So now we want to save the file first. You go to save, click on save button. Save. Okay. So you didn't selected the folder.
SACS.
Okay, go to SACS. Okay, so here you click on no. You save it. Save it there. Now copy that folder location. Copy that folder location.
This one.
Copy it. Now go to that blue one of the SACS, not here. Blue one where analysis generator is there. You paste it there. Okay, we already have.
It's done.
Click on go. Go.
This one.
You maximize it. So Ganesh and Arun, are you guys still here?
Yes, sir.
Okay. Now click on the analysis generator on the top. After files. Okay. So here you can you at the top you see file ID. No, not files. Click on analysis generator. On top you see reset output ID, file ID. Just on top of analysis generator. Analysis top of right side, right side, right side, right side, right side, right side.
File
Here.
ID.
File ID. So click on input INP. Just click on that. Now, Ganesh and Arun, did you select that?
Yes, sir. Yes, sir.
Okay. So here, usually when we save these files, we save with name. Now we are not doing since we are going for a trial. Okay. Now click on the type.
Then,
No, come down, down.
okay, here.
Type. Next.
Select analysis type.
Yeah. You go to
Static.
static. So what is static? Which doesn't have varying loads. Okay. We will go for basic static analysis. So we collect for statics. So no, don't go down. Don't go down. Don't go down. Go down. Okay. So let's understand what all things are. First one is static analysis. Then there is basic static analysis. We are going to do the basic static analysis right now. If you want to have gap analysis, click on that. Click on that. Basic static. See here we have a lot of options. Basic static analysis, topside static analysis with the pile soil interaction, monopile analysis, static analysis with the gap elements, large deflection, full plastic collapse or pushover analysis, create pile head super element. We have a lot of options, but we are not going to do any of those. We select on basic static analysis. Click on the first one, basic. Okay, now make sure our current working directory is correct. Now it's correct, right? Because if this is different, what will happen is our results file will be stored in some other thing. Okay. Now, and we are not giving any environment loading right now. Leave it. Solve option. Click on that. So we are going for everything default. Okay, we are not changing anything. Close it. Now we are going for element check option. Click. So one advantage of SACS is in ANSYS and all, what we usually get is we will get only the stress. Then we need to check against some codal provisions. But here what we can do advantage is we can select the code and it will check against the code. You click on the code criteria. See, we have all the WSD, AASC, APRP, WSD method. We will have, come down, if you come down, there are LRFD method. There are NORSOC, Eurocode, Danish code, British code. So according to your client requirement, you can change the code. Okay. Now we will stick on to the first one. AAC 9th, because that is very conservative and most of my clients are asking us to perform analysis in AAC 9. So rest of the things we are keeping for default. Click OK. Tubular check we are not going to do right now. Leave it. Now coming to section library. So our sections are defined based on different codes. So we will select AAC 13th itself or 9th also we can change to 9th, AAC 9th. Now coming to the SACS model file. This is important. Here we are selecting which input file to take on. You click on the top, right side. You have 3 dots, no? Here we need to select which SACS input. This is our SACS input file. So INP means it's a SACS input file. Okay. So it will create other output files, that is SCF, PSVB. PSVB is our result view. Then there is a run file as well. then all the output will be listed in LIST. So Arun and Ganesh, have you selected all these?
Yes, sir.
Now what we are going to do is we are going to run this file. Okay. On the top, click on run analysis. Okay, so we got the result file. Listing is saying that there is no errors. There is no error in our model. So now you click on PSVB file, that is output file, post to a database. So input is proceed. No, down, come down. Click on that second file, second file. No. Where?
Here, output.
No, not output. In error log itself, there is a second file, no? PSVBINP. PSVDBINP. Come
This
down.
one.
No. Wherever your cursor is, just top of that.
Database generator.
Yeah, click on that file, not on the message, file.
Should I click again?
No, wait, let's see. You click again. Yeah, you click again.
This one.
No, just proceed, right? It's opening proceed again. 1 minute. You go to files. No. Near analysis data. That's result viewer. No, that is result viewer only. Click on the window. Click on the window. Maximize it. Okay. Now go to labeling options and display. Labeling options. No, below the joint, there is labeling option. Below the joint, no. Yeah, that one. Arun and Ganesh, did you get this one? This window?
Yes, sir. Label option.
Okay. So this is the result file. So now here we can see the stress and everything. So you labeling option top results come to member. Click on that. Maximum combined UC. Apply. See, our thing is failing. So maximum UC should be 1. But our one is failing because it's understandable because we gave a mock-up.
Minimum section.
Minimum section. So this is how we will do it. Before leaving, I will show you few more things. Okay. Now, in the display itself, you see deflected shape.
Sir, how you find it's failing? The value is greater than 1.
Now here the greater. Now the value is 19.63, right?
Yes, the maximum value should be 1, so it is greater than that.
Oh, 1 minute, just hold on.
Okay.
Sorry, but I can look out. Hello? I'm looking. Hello. So UC means this is unity check. Do you know the concept of UC?
No, sir.
Okay, I will tell you. Okay, so let's say our yield strength is 240. Okay, so I will share the screen. I will come to UC. I will just show 2 more things and I will come to my screen. You go to deflected shape option. So you click on load case to display. Click on L01. You go to come down. Deflected shape. Click apply. See, it will show the deflection over here. Okay, so when you click like that, it will show the deflection. And another thing is, you go to member again. Member review or redesign. Click on that. You click on that member, which we have. So here it will show separate use. I will explain what is UC. So it will show which code we used and where the. So if you look at the top section shows which section we have used, and it will give options to change the section and recheck it. Then LB is the effective length in bending. I will explain it later. Then FY is our yield strength. LOC is the location of the member where it is failing. So here LOC 0 means the beam started at the first joint, no? So beam is failing at the 0th. If you want to see the UC at the other ends, you can change that location and recalculate it. I will explain everything later. But now come down. If you want to see the moment diagram, click on moment diagram. So here you will show the joint location, shear force diagram, and bending moment diagram. From here, close it. Close. Click on the detailed report. So if you expand it, you can see all the calculation which was performed. Down. So all the basic properties, what are the member properties, what are the end forces, means force at each point, what were the actual stress. So what are the allowable stress? See, I will tell you why this one got up. Can you maximize it, Sandhya? See, if you look, our allowable stresses are 148 in axial, and minor axis bending is 177, major axis bending is 91, shear in 99, and Euler buckling is 38. If you go top, little bit, top, go. See, in our major bending itself, the stress is too much. So what? You click on calculator. Calculator. Click on search calculator.
Here in system or here?
System calculator. No. So that type 1802 by how much? Minimize it. 1802 by 91. 1802 divided by 91. So unit, the UC means we are checking the actual stress against allowable stress. So we have a yield strength. From the yield strength, as per the codes, the code will tell, okay, this is your allowable stress. Maybe 0.6 times of yield stress, maybe 0.8 times. It differs from code to code. But our actual stress may be something. Okay. So unity means it will check against the actual stress by allowable stress. So actual stress should always be less than allowable stress. So if it goes, if actual stress is less than allowable stress, the unity will be always less than 1. That means our structure is safe. If the actual stress goes above the allowable stress, the unity will go, UC will go above 1. Then it will fail. So that's the concept of UC. Did you get it, Arun?
Yes, sir. Clear.
Okay.
Yes, sir. Now it's clear, sir.
So in SACS, we are checking against some codal provisions, codal allowables. That's how I told it is failing. Okay. So this is how we usually do an analysis. Okay. So this is just basic. I just want to show you till how we do analysis. We will go through each step, everything in detail. I know the analysis part, I rushed it because we have 1 week. If you want to do some sample problems, no, I just want you to explore. Okay.
Okay.
From next class, we will take each case one by one and we will do sample problems together, because today we didn't have much time due to introduction and small things. So what I would suggest is I send you that course links, go through that, understand basic concepts, and take sample problems in the internet, no? Our normal what? Simply supported beam, cantilever beam, our normals, our engineering problems, no? Try to model in SACS and see.
Okay.
Okay, sir.
You
Okay.
do something hands-on so that daily at least spend 1 hour.
Okay, sir.
Okay, for that you to familiarize. And one more thing, if you have any doubts, list out all doubts and send me by Thursday, because when I come to class I need to prepare for that also, right? So
Okay, sir.
so if you have any doubts, list out everything and send it in our WhatsApp group. I will explain it to you during our class time. Okay.
Yes, sir.
Are you guys clear? Are you guys understanding or following me?
Yes, sir. Yes.
Okay. So if I want to improve in any area, let me know. I can help you out. The first and the only priority is that you should guys follow and learn.
Okay, okay, sir.
Okay. So I can put extra hours. It's fine. I don't mind putting extra hours, but you guys should follow. That's our
Okay,
main
sir.
thing. Okay.
Okay.
So can we close today's
Um,
class?
Yeah,
sir,
yes, sir.
one small doubt.
Okay.
Now this beam has failed, no?
Ah,
Now if I want to give a bigger section, now
ah,
how to do? I have to go from the start or
yeah. Now from the result file, we cannot do anything, Sandhya. For
okay,
everything, we need to go to that SACS INP file. You close the all window. You close all green windows. You keep only the blue one. Ah,
this close.
close
This
all
also
green windows. Now
okay.
maximize that blue window. Maximize it. Go to
Okay.
files.
Fine.
No, not there, not there. Our window was there. No? Click on home. Near analysis generator files were there. No? You shall
This
have
one.
so click on that SACS third one. SACINP.INP.
Okay.
Click
Double
on that.
click.
Ah, what I will usually do is I will save this file as save as. Click on save
Okay.
as.
File.
Save
File.
as. Okay. Okay, no, don't change. Click on OK.
Okay.
You click on the name. Delete INP. Delete INP. You type trial 01. Trial 01. Okay, save. You now define a new member property. Okay, assign that member,
Hmm.
run it, see whether it is passing out, or if it's failing again, select a new one. So
Hmm.
now I will tell you how to run the analysis also. Go to again analysis generator, blue window.
This one. Hmm.
Go to top file ID.
This one.
No, file ID,
Hmm.
file ID.
This one.
Yeah. Drop down.
File 01.
File 01. Now click
Hmm.
on analysis generator.
This.
See, our output files were earlier named with that INP. Okay.
Hmm.
Now we will change these names. So near that file ID, near file ID, down there is a reset output ID. No, click on reset output ID. What it will do is it will rename all the output IDs.
Okay. Okay.
Okay. Now you change the SACS model.
This one.
No, not edit. Three button. Click on SACS file, open. Now just run the analysis. We didn't change anything. Just
But
run
we
the
didn't change.
No, we didn't change anything. I just want to show you how we can have multiple analysis files.
Okay.
Okay, now you again go to files.
Files.
See, now we have one more file.
Output.
If we didn't change that name, what it will do is it will what?
Override.
Override. It will override. So now if you change the name like this, you can have multiple files.
Okay.
Because these are SACS files, it are very small size. So it is okay to keep few iteration files till you reach a final model.
Okay.
Sometimes we used to keep 50, 60 iteration files like this.
Okay.
And we will delete everything once we confirm a model. Because sometimes we may make a change, and if you want to revert to back, it will be tedious process, change every time. No, if we have something that is partially working, we can again go back to our previous trial file and work on it. So like that, you can work here.
Okay.
Clear?
Yes, sir.
Okay. So Ganesh and Aaron, you are also able to follow it, right?
Yes, sir.
Okay.
Sir.
So what I would suggest is take simple problems. Take simple problems in or civil engineering, strength of materials. Try to model that and see how the deformation, deflection, everything happens. Okay. I just
Okay,
want
sir.
you to explore. We are not going deep today. We didn't went deep today. But from next analysis, next day, we will go everything deep.
Okay, sir.
Today was
Okay,
just
sir.
introduction.
Okay, sir.
Yeah. So are you guys happy? You learned something new today.
Yes, sir.
Yes.
Okay. Okay, good. So we will close today's session and we will meet on next Saturday, right?
Yes, sir.
Yes, sir.
Okay. Okay then.
Thank you,
Thank
sir.
you everyone. Thank you. Thank you.
Thank you,
Okay.
sir.
Thank you.
Thank you very much.